Thank you for getting to the last video, and this is going to be the shortest one. And we're going to talk about these two highlighted words, interpolate and extrapolate. Some of the funnest words to say in math, if that's a word. I don't know, funnest. It says you can use an equation of a line of best fit to make estimates or predictions. So this is the real power of scatter plots, using known data to figure out how something might happen. So when you use a line of best fit or its equation to estimate a value between data points that you already know, so within the data, it's called interpolating. And when you make a prediction outside the range of data, it's called extrapolating. And we're going to go back to that newspaper one in a second here to answer some of the questions. And the first one is an interpolation question. It says use the graph to estimate the amount of people who got their news from the newspaper in 1999. All right, so let me go back to our work here that we already started. And 1999 would be, remember, 9 years after 1990. So we want to go to the 9 right there. Let's use a different color for all this, like hot pink or something. So I want to go up. I want to go up, 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 up into the same spot. And it looks like right there, like a big old dot. And what I want to do is I want to look left. So if I go along this line, looks like it hit exactly between 60 and 62, which would be 61. So I just made an interpolation. It's that simple. Because I have this line of best fit, all the points along this line are my best guesses at what would happen that year. And our best guess for 1999 would be 61%. Now, that doesn't mean if someone actually took a survey in 1999 that it would be exactly 61, but it should be close. We're hoping that it matches pretty well. So let me go back to this, and we're going to answer 61%. And all we did was looked at the graph. So let's see what they're asking for next. Now it says extrapolate. It says use the line of best fit to estimate the readership in the year 2010. So that would be beyond the data they collected. Remember, 2006, I think, was the last year that they had a piece of data. And we want to go beyond that. So that's why it's called extrapolation. And there's a little caution thing here. It says extrapolations can be misleading because they assume that the linear trend continues outside the range of data collected. The farther out from the data you predict, the less reliable your prediction will be. So remember all those really simple scatter plots we made, like age and height? So if you had a graph with age down at the bottom, height right here, and you had from age, let's say 0, well, I guess 0 should be here. You get the idea. 0 to 20 generally goes up, right? Height goes up. Well, it kind of stops after 20. But if you didn't know that, if you were unfamiliar about how humans grow, you might say, oh, but at 40 you're going to be way up here. You're going to be like 10 feet tall. And at age 80, you'll be like 40 feet tall. So you can see as the further out you go, the more likely you are at just being totally wrong. So extrapolations are a little dangerous, but we make them if it makes sense to. And in this case, I think it could make sense to. All right, we do it differently. So let's go back to that picture again so we can look at what 2010 looks like. 2010 would be 20 years after 1990. Year it would be. So if you wanted, you can get a ruler out and continue this line, and that would be okay. But we want to use the equation. We want to actually use this equation to help us. So can you remember this? I'm going to have to copy it again. So let's see if I can remember. Things usually vanish from my brain as soon as I don't see them anymore. Equation for line of best fit was y equals negative 0.61x plus 66.5. I think I did it. Let me just check to make sure. Because there we go. I was unsure of that last part. So we're going to use this to make our extrapolation. So since the x values represent years past 1990, we should plug in for x. So what do I plug in? Well, 2010, we already said it once, is 20 years past 1990. So I'm actually, the x value would be 20. And then we're going to solve for y. Solving for y will represent readership in 2010. And we're just make sure that people know it's an estimate. It's not, we're not going to know that for sure. We don't really have data on that. So here's the math. Again, I'm going to copy that formula down. But I'm going to put a 20 in when I saw an x. I see an x right there. That's the only one I see. And we're going to use a calculator because that's just what we do. Actually, I can do this part without a calculator. Negative 0.61 would just double to negative 1.22. I'll check that to make sure I'm right. Alright, I knew I'd make a mistake. So it's 12.2. I just put the decimal in the wrong place. Let's cheat. Let's write it like this. No one will ever notice. Negative 12.2 plus 66.5 equals 50... Is it 3 point? No, I'm forgetting. Let me bring my calculator back. 54.3. I had it backwards. 54.3. So that's the percent. So in 2010, our line of best fit estimates that only 54%, or a little over 54% of people will get their news from the newspaper. And then we have just made an extrapolation by plugging in a number into the equation that we have made. And that is the end of the video. It's a little longer than I was hoping for. Thank you for sticking with me. You guys have earned some brownie points. Good night.